Okay, I had a question regarding summary routes and finding summary routes. And the question was, what if the networks don't increment like by one? So in this situation, you have the 10.2.1 network, the 10.2.2, dot 3, 4, 5, 6, 7. They're incrementally, they go up by one. Let's change this around and do it differently. I'm going to change this one to the 0 network, and then now we skip from 0 to 2 and 3, 4, 5, and then 6. We'll change the 6 here. We'll change that to an 8, and then we'll change this one to, let's say, a 12. Okay, so now you could see that the networks aren't all in order. You've got 2, 3, 4, and 5, but then it jumps up to 8, 12, and of course you got to jump from 0 to 2. So they're not incrementally by 1. The exact same principle applies for figuring out your summary route. So for instance, okay, I've got 0, 2, 3, 4, 5, 8, and 12. Okay, so now I'll go to this other page and where I've listed out in binary. Okay, these all are the 10 right here, right? 10's written out the same, and then dot 2, right? They all share those in common. And then now we've got to do the 0 network. So 2, 3, 4, 5, 6, 7, 8 dot 2, 3, 4, 5, 6, 7, 8. So that's right there. That is dot 0 dot 0. Okay? That's the dot 0. 10 dot 2 dot 0 dot 0, right? And then of course we got the 2, 2, 3, boy, that's really annoying. 2, 3, 2, man, that's annoying. Whoops. Okay, there's the 2 network, right? And then we jump, then we have the 3. All right. Then we have the 4. All right. Then let's see here. The 4, the 5, the 8, and the 12. Okay. All right. There's the 5. Now the 8. All right. All right. There's the 8. And the 12. Okay. And then all of these will all have zeros here, right? They're all going to have zeros afterwards. So this is the dot 2 dot 0. This is 3 dot 0, 4 dot 0, 5 dot 0, 8 dot 0, and 12 dot 0. Okay? All of these afterwards, of course, are all going to be zeros all the way across, right? Okay. All right. Sorry about that. Okay, so now we just look for the last common bit. So if we look for the last common bit, you can see here that these two share ones in common, but then you've got zeros here, right? All right, so then the last common bit, the last common bit can be ones or zeros. In this case, it happens to be, but they all have to be the same. So in this case, it's right here, all of these zeros lined up right here. That is the last common bit in order. The lowest address is 0.0. So the base address is going to be 0.0, right? Can't be higher than that. And it's going to be slash 8, right? You count from the left to right. 8 bits, 16 bits, 17, 18, 19, 20. So it's going to be a /20 address still, because this is, or that's what it's going to be, these zeros lining up right here. I can get my drawing tool and draw it out for you if I had the line here, but it's right here. Let's see here. I'll draw a line on the next line to show you where it's at. Right here, where this 0 lines up, that is the last common bit. So this is, the networks jump around from 0, 2, 3, 4, then they jump to 5, 8, 12, doesn't matter, still the last common bit.